interesting. Fascinating.
So, Jane's here? Somebody, who texted that? Somebody texted you.
Dave.
Dave, oh, okay. I wasn't quite sure. Alrighty, well, welcome everybody. Sorry I'm late.
Oh, you're just putting it up.
Let's see. Should we go ahead and do some introductions and everything like that? And also, should we do a sign up, Jan?
The sign-in's good,
Is it already been done?
except for you.
Except for me, because I'm late. I know, sorry.
I must be waiting, paying meds, don't pay any attention to me. Here you go.
Yeah.
I'm gonna pass that one up.
Sure.
I had a little issue, but that's neither here nor there.
I have a shirt like here. I need to talk to you after.
Okay.
Okay, well, anyways, welcome everyone. I guess we'll start with a few less familiar faces. We'll start with introductions. My name's Doug Gooden. I'm the president of NECO.
Okay. Mark Randall, fairly new member. I was a member in the 90s, but it's been a long time ago.
Janelle Burgard, I've been here a member since the flood.
Wes Giles, I just started last month.
Sanford Pomerantz, I've been interested in astronomy since a teenager. I'm the local psychiatrist to keep everybody sane.
That's like trying to sweep back the tide.
It's Ed Warder.
Jason Price, first time. Angel's been bugging me forever, so.
Good job, Angel.
You know, I try. Angel Romero, board member.
Gary Hug, Dinosaur.
Jeff Goodman, pretty new member. Friends?
Just Brent.
Tony Castaneda.
Courtney Reese, new member.
Michael Reese, this is our second time here.
There we go.
Russell Valentine.
Well, welcome everybody. Good to see a good turnout. Welcome to those of you that are joining us online as well. Okay, announcements. First of all, the general meeting, which you must know about because you're here. Couple things to kind of be aware of. There is a public night this Saturday night. I think Dave has been kind of organizing that a little bit. One thing I did want to add, which he would probably add if he were here, that if you're even relatively new members, please come out. It's not like it's reserved for people that have been a member for a long time. I actually have not really been a member of the club for that long. So, but we welcome everyone out there. There's certainly a role for everyone. For those of you who may be new members, what a public night is exactly that. We have an open house at our observatory, which is out near Eskridge. Members of the public come out. We usually have a few telescopes set up, and then the ones that are permanently mounted out there are usually pointed at some target that we think is interesting. There's usually a little bit of a presentation. We had a pretty good turnout last time, as I recall. We had, quite a few people that came. So if you've not been out to Farpoint, this is a good chance to get out there and kind of check the place out. So please consider attending. And those of you that have kind of played roles before, again, I think Dave is kind of keeping track of all that. Unfortunately, I'm still a little unclear on my status for Saturday, but I'm hopeful. Okay, so that's this Saturday. Also notice, by the way, that the next public night is scheduled for July 8th. It comes a little bit earlier. And by the way, is that also a board meeting? Mm-hmm. Okay, so we'll those of you that are on the board will have that. Members night. The last one was scheduled for what? Last Saturday night? Mm-hmm. And I think that didn't work out. Do we have another one of those scheduled?
It's scheduled, but I don't remember when it is.
Okay. And I have not actually looked at any reliable weather forecasts for Saturday. Has anybody been keeping track of?
I checked just before I came in, they're split. Some of them say it's gonna be really cloudy, and then others say it's really clear. So
Yeah.
it's all a matter, there's some fronts coming in, it's a matter when they clear out, so.
Yeah, I haven't really looked too closely at all that stuff yet.
Mhm.
I generally don't pay much attention to weather forecasts until about now. Two days before is about when you started to get into the window of when you can start really relying on them. So, but again, if there's we'll probably need to keep an eye on that and call that off if it seems appropriate to do so.
Russ, if we cancel, you still put it on the website, right?
Mm-hmm.
Yeah.
Anybody else have any announcements? Anything that they want to bring up or share?
Is the phone at Farpoint working?
No.
No.
Because of the internet, yeah. Yeah, so sometimes people will call to see if it's on or not, and this time it won't. They're doing construction out at the school, and they have managed to disconnect our internet connection, which is the phone and everything else, so.
Yeah.
But Russ does post it on our website, and it was canceled.
This Saturday.
Has there been any update on that? Again, Dave's the one that kind of keeps track of all that. And,
Last I heard that the school said that they had parts on order that was supposed to be in this week. And then after the parts come in, then they've got to have, some kind of group working on them and hopefully knows what they're doing. And so it looks like it's going to be at least another week, I'd say. But my guess is it'll be in the fall.
yeah.
It'll be when school starts back. That's when they're going to get it fixed. They won't do it for just us, I don't think.
Well, that's kind of disappointing, obviously, because it affects pretty much everything that goes on out there, obviously. It's going to be kind of like one of those things that's always a week away. And, well, that's unfortunate, but hopefully Dave can kind of at least keep the problem in front of him. Last time I was out there, which was, I don't know, a couple of weeks ago now, I guess, there were really a lot of people working. It looks like whatever it is they're doing out there, they're really kind of, it's finally underway, so. Anyway, any other announcements? Any other club business? No?
I'll be bringing the big camera back out for that night and probably take it back home afterwards, but
Okay.
It'll be available.
Okay. Okay. Well, moving on then. Just a few announcements. First of all, welcome to summer. Today is the first full day of astronomical summer. So yesterday was the summer solstice. We had a presentation on this a little while back, but basically what happened, I think the actual time was like 11:27 or something like that, Central Time. The subsolar point corresponded to the northern tropic, which meant that the Earth is now was then inclined with the northern hemisphere directly towards the sun. So that starts the beginning of astronomical summer, the time of longest days and shortest nights, which is not particularly good for astronomy, but it's nice for other things as well. So anyway, welcome to summer. A couple of other things that kind of caught my attention, items I thought I'd kind of share with you. First of all, we talked a little bit about this in last week's meeting, that there's this program that if you're interested in kind of data, basically, but don't have access to a telescope or not that interested in one, you can assist NASA in finding exoplanets. Basically what you do is you take the material from some of the orbital satellites and just look for kind of anomalous light curves. It's really kind of an interesting thing to do. There were 3 found from the Kepler data. This was Kepler was a satellite that was launched, I don't know, several years ago to detect transiting exoplanets. Was no longer operational. It's been replaced with this thing called TESS now, which is a kind of a next generation one. But they're still finding stuff in the Kepler data set, and this was a detection that was actually made by some of those individuals that are sort of volunteer observers. So if this is anything that you feel like you'd be interested in doing, there's still definitely a role to be played in this. I thought this was kind of an interesting little news article. And the 30th of June is Asteroid Day. Anybody know that? Asteroid Day has been, I don't know, 5 or 6 years now that they've been doing this. It's basically to raise global awareness for the importance of minor planets and also some of the risks associated with them. One of the people that was kind of instrumental in setting up Asteroid Day was a retired astronaut by the name of Russell Schweickart, who was always one of my favorite, kind of a space program nut. And Rusty Schweickart was always one of my favorite astronauts because he was kind of a free spirit. He was a little different than some of the other ones. And he flew, I believe, on Apollo 9, and has since become one of the real kind of organizers and driving forces behind Asteroid Day. So this is the 30th of June. There's actually quite a few online presentations that are associated with this, so I probably will try to watch some of those, but that's a kind of a good opportunity to sort of see what some of the state of asteroid research and interest is right now. So that's the 30th, which is what, next Thursday, next Friday? Anyway, other asteroid news. It's been kind of a good month for asteroid news. This particular spacecraft is finally going to be launched. This was the Psyche spacecraft, designed to go to an asteroid that's mostly metal, right? And this is kind of an unusual one, and it's thought to probably be a piece of the kind of metallic core of perhaps a protoplanet or a planet that didn't exactly form. So it's kind of a little bit of an unusual one. I like the fact that they refer to it as the $10 quadrillion asteroid. I'm not sure whoever came up with that really understands economics. Because if you had this much metal, it's not going to be worth that much anymore, right? It kind of reminded me of there was an episode, I used to like the Twilight Zone, anybody remember the Twilight Zone? There was an episode where some people rob a bank, and then their plan is they're going to suspend themselves in a cave with all the gold and wake up some years in the future, and they're going to be fabulously wealthy with all of it. Well, it turns out gold has no value whatsoever in the future. So this I don't know, in a weird sort of way, this kind of reminded me. Yeah, this kind of reminded me of that. If you bring back an asteroid that you think is worth $10 quadrillion, you got that much stuff, it's going to not be worth anywhere close to that. Anyway, but the fact that, the scientific importance of this is considerable. So this is an interesting thing. There's another picture of what this thing actually looks like, 16 Psyche. Weird looking thing, but mostly made out of metals. And speaking of which, I was thinking next month, to do a presentation on the moon. Because, we kind of overlook the moon a lot, except when we're cursing it for being too bright and drowning out all the other stuff we want to look at, right? So I thought we might do something on the moon. Although, again, I say this every time, and it's true every time. If there's anything you want to hear about, or if there's anything you want to talk about, let me know, because, I'm very glad to cede the floor. So, but this I thought was interesting. There's still an awful lot about the moon that's unknown. And it was thought for quite a long time that the core of the moon actually wasn't really solid. It was more of a liquid metal, kind of molten metal. New evidence suggests that it is solid, much like the core of the Earth is solid. And the composition of its interior composition is somewhat different from the Earth's, but this would be a case where it's similar. So I think what I'm thinking is maybe expand a little bit more on that for next month's meeting. But again, please give me feedback. If there's something you'd like to hear about, I would be more than happy. Other asteroid news. This is Max Wolf, and yesterday was his 100 and something birthday. Can't do arithmetic that well in my head. Max Wolf was kind of well-known astronomer, was one of the pioneers of astrophotography, but not astrophotography necessarily for the artistic value of it, but for the science value of it. And one of the things that he was a pioneer on, and among several things, was he was one of the first people to search for minor planets, search for asteroids with photography. Before then it was done kind of the old-fashioned way. People just literally look through telescopes and see if they saw something that shouldn't be there. Probably an especially efficient way to do it. So Max Wolf was one of the first to use photography. And photography in those days was very, very different from what it is now. They used metal glass plates, and you had to make them yourself. This wasn't something you could go down to the drugstore and buy or something like that. they actually had to take these glass plates and put the emulsion coating on them, and it was a very, very complicated, very difficult thing to do, because the coating had to go on just the right thickness and just the right uniformity and all that. So it was a very, very exacting thing. But Max Wolf used this technique to discover 248 asteroids. Was at one time the leading discoverer of them. So yesterday was his birthday. So I think those of us who've photographed asteroids from time to time, kind of hat tip to Max Wolf. Here's another anniversary. 1978, June 22nd, today, 1978, Charon was discovered. Charon is the moon of Pluto. It was discovered by this guy, James Christie, still an active astronomer now, still works at the U.S. Naval Observatory in Flagstaff. Worked there, was on the staff there at the time, and was imaging Pluto. This is how they could image Pluto in those days. We had much better views of that now. And he noticed this little bulge thing on the side of it here, and that bulge would sort of move around as they looked at it through time. It would be there and it would not be there. And they considered how it might possibly be errors in the telescope, errors in the photographic plates that they were using. Eliminated all that and eventually arrived at what the truth was that essentially Pluto and Charon are kind of a double planet system, really. And so that he was discovered that there's a kind of a more modern view of what the two of them might look like. Named it Charon for a couple of reasons. Charon was the boatman that took people across the river Styx, right? And Pluto was the lord of the undead. So Charon was the other thing was his wife, James Christie's wife, was named Charlene, I believe, and everyone called her Char. And he wanted to honor his wife and couldn't exactly name it Char or Charlene, so he named it Charon in honor of her. So that's the story behind the moon of Pluto, Charon. And of course, we've had size comparisons of the month for a little while now. Hopefully we're not getting too tired of these, but this, for those of you that are maybe new here, there's this strange practice that seems to be happening more and more of people comparing Earth crossing or Earth approaching minor planets to mostly animals. So we've seen them that have been compared to, penguins. I believe Darth Vader was one that we looked at last time. I don't know, probably some others. This one's a little bit different. The original thing I was going to put up here was comparing this particular Earth crosser. There's the designation of it right there, to two Titanics. But I thought, given the news now, the Titanic and all that, I figured maybe we'd want to kind of maybe stay away from that. But this is a relatively large one. So according to the San Antonio Express News, this one's big enough to crush San Antonio. I'm not exactly sure what they mean by that. I'm not sure what it means to crush a city exactly, but if this thing impacted on San Antonio, it would certainly, or anywhere near it for that matter, it would certainly be a catastrophic event. This one is probably, on the order of, I think, around 150 or 200 meters. So it's big. It's big enough to actually pass through the atmosphere and do some pretty significant damage if it was to impact. But anyway, this was the size comparison of the month. Kind of a less exciting one, I think, but then comparing it to Darth Vader's or penguins, but there you go. But I did look up some of them on the Jerusalem Times, which is where the weird ones usually come from, and not a good month for that. A little underwhelming. So anyway, that's this month's asteroid size comparison. Maybe we should retire these. What do you think? Kind of the joke has been used up, maybe. But anyway, it's continues to be perplexing and funny to me to kind of read these things. Anyway, that's that. All right. Any questions or anything before we? Okay, so as we usually do then, kind of take a little bit of a look at a particular constellation. And this one was, there's a reason behind it. So I thought one of the constellations I wanted to focus on was Cancer the Crab. So there's what it looks like right there. It doesn't look a thing like a crab to me. Of course, Leo doesn't really look all that much like a lion to me either. But anyway, the reason why I selected, there's a couple reasons why I selected it. First of all, constellations I wanted to focus on was okay, why is that happening? Am I hearing that? Is everyone else hearing that? Okay. Anyway.
He's playing psychiatry games.
Okay, all right. Anyway, sorry. So cancer, and at first glance, it might not, seem like a particularly exciting constellation. It's relatively dim. We're actually starting to get to the time of the year where it's not that easy to see anymore. It typically is easiest to see, I think, beginning in March, and now it's kind of getting to the point where it's really low in the sky and probably won't be visible for all that much longer. But there is a reason for it, and I'll kind of reveal that as we go along here. So I picked it this month for a reason. One of those, actually two reasons. One of them was that it kind of follows a little bit from what we talked about, the kind of constellation focus we had during the last meeting. So it's one of the constellations of the zodiac, right? The 12 or 13 if you count this one, which I don't think the astrologers have quite caught up with that yet. But anyway, it is one of the dimmer ones. I think the brightest star in it is 4th magnitude or something like that. So they're relatively dim constellation. And it's kind of right next to Leo, and that's part of the story of all this. So if you remember the presentation we had last month, this one is kind of part 2 of that, I guess you could say. So in terms of where you find it, again, it's not easy to see now. It's in the western sky right now, just barely above the horizon at any time you can see it. But if you look at it, I guess in March or April when it's a little more prominent in the sky, I personally find it by finding Gemini. Gemini is one that for me is always easy to find, right? Because Castor and Pollux are fairly easy stars, at least for me to find. So I always think about it, I guess when you see Gemini depicted in art, these stars along here are always shown as being the shoulders, right? The twins' shoulders. But to me, it looks like stick figures holding hands. So I think of it as, there's a stick figure and a stick figure and they're holding hands. And if you connect all that, it kind of points right to Cancer. Or you can look at it by looking at the sickle of Leo, right? That's another way it kind of points toward it as well. But regardless, it's sort of this kind of upside down Y-shaped constellation here. And there are some fairly interesting objects in it. But again, the reason why I picked it is twofold. First of all, the continuation of last month. So those of you who were here last month, you recall we looked at Leo last month. And when you tell the story of Leo, you begin to tell the story of one of the Greek heroes, Heracles or Hercules. So the story behind Leo was that Heracles, this Greek hero here, was an illegitimate son of Zeus, the king of the gods, right? And as we've talked about a number of times, the gods were very poorly behaved. And one of the things that Zeus did was father a lot of children out of wedlock, including Heracles. This made Hera, his wife, very unhappy. Hera was the goddess of love, right? Apparently not exactly a bit of a jealous goddess of love, was not very happy with Heracles, did not care much for him because he was an illegitimate child. Even though Zeus named him after her, Heracles, as a way of kind of trying to, patch it up a little bit. Didn't work, apparently. So Hera was quite unhappy, and Hera essentially cursed Heracles as a older man. Actually, when he was a baby, she sent a snake to try to kill him, and Heracles killed the snake. So, he was a kind of a hero even when he was a baby, still in diapers. But anyway, at one point, Hera cursed Heracles and inflicted madness on him. And in consequence of that, he murdered his family. This was obviously traumatic for him because he was, unlike most of them, quite attached. So he had to be punished, and the punishment that Zeus prescribed was that he would have to perform these 12 labors, right? So the 12 labors of Hercules or the 12 labors of Heracles. So last time, when we talked about Leo, that was a reflection of the first labor. The first labor was killing the Nemean lion, this beast, this lion that was considered to be impervious to weapons. Heracles did in fact figure out a way to kill this thing. He trapped it in a cave, killed it, skinned it, wore the skin as armor for the rest of his warrior career. And so you often see in depictions, you see Heracles or Hercules with a lion head on, and that's the head of the Nemean lion. And that was the first labor. The second labor is where we get to Cancer, we get to the crab. The second labor was he had to, it always involves slaying. You had to slay the Lernaean Hydra, right? So the Lernaean Hydra was this monster that lived in the Lernaea swamps and preyed on the locals. It was this 9-headed kind of snake creature. One of the heads was an immortal head, and the other 8 were regenerative, right? If anyone cut one of these heads off, it would replace with 2 others, which obviously made the Lernaean Hydra kind of a problem to kill. Heracles, being Heracles, figured it out. He actually, what he did was he drafted his nephew to bring a torch, and whenever Heracles would cut one of the heads off of the Lernaean Hydra, the nephew would immediately cauterize the wound, basically, before it had a chance to regenerate. So eventually, using that approach, he defeated it. He cut off all 8 of the regenerative heads, then cut off the immortal head, which I guess means it wasn't immortal anymore, and buried them all and completed that second labor. So that was the second labor. Well, here's where Cancer comes into play. Here's where the crab comes into play. Again, Hera was not fond at all of Hercules, wanted him dead in the worst way. And so in the midst of this battle that Heracles is fighting with the Hydra, I don't know where this particular piece of artwork originated, but it kind of shows the crab, right? She sent this giant crab to try to attack him while he was fighting the Lernaean Hydra. Of course, this didn't really faze Hercules very much because he was Hercules, right? So he smashed the crab pretty easily. But Hera still felt like the crab deserved a little bit of honor, so she placed it in the sky as a kind of a tribute to its role in at least trying to defeat her hated, illegitimate son. So anyway, that's the story of Crater, the crab. It's of course now one of the zodiacal constellations. It's one that the planets actually pass through, so it lies along the plane of the ecliptic. But that's its story in mythology. So I know that's kind of a long series of events there, but I thought it kind of followed nicely from last month's thing. So here's the kind of layout of it, I guess astronomically. There's a couple of pretty interesting items in it. One of them is a cluster called the Beehive Cluster, M44, which is a naked eye cluster. You can see it. Good dark night, good eyesight, better than mine. You can actually see it. So there's kind of what it looks like. About 1,000, an open cluster, about 1,000 stars. I've seen it through binoculars, and it's a very pretty sight. And probably March would be the best time to see it, maybe February, somewhere around in there. So this is a kind of a famous, one of the Messier objects, so one of the kind of famous objects. Another cluster, M67, the King Cobra cluster. I'm not sure exactly what the origin of this particular name is. This is another one that's pretty good size. If you look at it, it's kind of down over here. If you look at it, it's much fainter than M44. It's not, you can kind of see it, I guess, as a fuzzy patch if you are somewhere where it's very dark, but not bright enough to really make out individual stars. What is kind of noteworthy about M67 is that it is an open cluster composed of relatively old stars. They are stars that are unusually old for being as close to the Earth as they are. And that's made this an object of some interest to people who are interested in stellar evolution, because it gives you kind of a place to look for these particular older sorts of stars. So, and it's also thought perhaps to be part of the kind of physically related to the Hyades cluster. They may have formed in the same event, basically. So it's a very closely studied cluster amongst astronomers who are interested in stellar evolution.
It's also a place where people have taken a lot of photometry measurements and it's kind of used as standards. So you could go in there and image that and pick the stars out, and all those stars that's in there with any brightness at all will be on a list, and you can kind of gauge your photometry that way.
Yeah, yeah, which is a pretty significant, very important thing. They also use, what is the other cluster that's used a lot for that? I think the Pleiades are used some for all that too.
They know right for some Pleiades.
But anyway, so yeah, this is a not one of the kind of ones that makes the lists of a lot, but it's a really important one.
It looks really nice in the telescope. I've shown people 67 versus 44, and this one wins out.
Yeah.
As far as just looks of it. I think it's the colors, but just the way it kind of looks. It's more clustery.
It's in about a half-degree field, so it's not that big and expansive. You can get it in one image. And
Yeah.
pick up a lot
It'd
of
be interesting to know if there's any in that cluster that are large enough to go supernova.
I don't know if there'd be any that would be that type of star. But I don't know.
I know
We can
there's
check
kind
it.
of a threshold in our own sun is not nearly big enough to go supernova.
Yeah.
You know,
But I do know they're a relatively older kind of metal,
Yeah.
less metal rich stars. So
yeah, it's a little harder to find than M44, but I always like looking at this one.
yeah. So it's a nice one. And there's a kind of an interesting exoplanet star with star with a solar system, 55 Cancri, right up here. And one of the stars, or one of the planets, one of the exoplanets, is 55 Cancri E, is probably essentially a diamond.
Right.
It is a diamond larger than the Earth. So again, if you're tempted to think, oh gosh, that must be worth even more quadrillions of dollars, first of all, you'd have to get it here. No particular way of doing that. And secondly, if you had a diamond that big, the diamonds would become not valuable at all. But anyway, the whole thought of a diamond that big is just mind-boggling to me. I don't really know exactly how that would have even happened. You get that much carbon compressed that way. The physical process behind that would just seems I don't understand. But anyway, but that's one of the other kind of interesting objects, basically. Okay, and then finally the second reason, which many of you probably have guessed already about why I chose Cancer as a constellation to look at, is we are now in a period where Mars and Venus are very close to one another, and they are actually kind of right on the boundary between Leo and Cancer. So right now I think Mars is in Leo and Venus is in Cancer, but they are kind of right on the boundary with each other. And that also sort of brings us to what I wanted to kind of talk about tonight, which is Mars and Venus. All right, well, questions, comments, anything? Okay, so I thought that given that we have a prominent show now going on right now, it would be a good time to kind of meet the neighbors. So we're going to talk a little bit about Venus and Mars. First of all, I guess we need to pull back a little bit and look at the entire neighborhood a little bit more, because I don't know, there's a lot of talk about classifying planets and, what is this, what is that, is Pluto a planet, isn't it, all that sort of thing. I do work with classification from time to time, and classifiers are kind of fall into one of two categories. There's lumpers and splitters, right? Lumpers are people that want to have a small number of broad categories, and splitters are people that, and if you start getting into things like planets and stuff, you can really start going down a rabbit hole a little bit there. But the major division, the thing that I think is the most fundamental division between the 8 objects that we recognize as major planets, it lies in the fact that there's these four down here, which have solid surfaces and are mostly made of iron and silicates. And there are these four out here which don't have solid surfaces and are mostly made of hydrogen and water ices. And there's a pretty sharp division between those, right? You kind of go from that type to that type without anything really in between. And that kind of suggests maybe a few things about how the solar system kind of came to be. So our neighbors, the ones that are like us, are sort of down here. So we're not going to think about these guys out here too much anymore. Maybe at another meeting sometime we can talk about gas giants. But I want to kind of focus on these down here a little bit and how they came to be a little bit. So in essence, what I want to talk about is how they came to be, how they're different, what's different about them, and maybe a little bit about why they're different. And then since these are also really prominent things really just in our culture in a lot of ways, I wanted to kind of talk a little bit about that as well. So we'll kind of zoom in and talk about the rocky planets or the terrestrial planets, they're sometimes called. That's a little bit of Earth-centric view there. But and we're going to kind of leave Mercury out of it. It's not because we don't like Mercury, it's just it's not one of our immediate neighbors. So we're going to kind of leave Mercury out of this, and we're going to look
There
at
is a spacecraft just about ready to get to Mercury.
which I think is the first one, right? That will have the first
This
mission.
close, yeah.
Yeah, which would be kind of an interesting thing to see. But we're going to look at these three, and if you kind of look at them, you begin already. You just looking at them, you already begin to get a sense of how they're different, right? Earth, obviously, abode of life, not just abode of life, but absolutely dominated by life and by living processes. The physical properties that you would observe if you observe the Earth are largely driven by the fact that it's life, a planet dominated by life. Free oxygen in the atmosphere, an atmosphere that's out of equilibrium, free water everywhere. All of those things are life signs. You look at the neighbors, not so much, really. So how did these kind of come to be? Why is it that this one has life and these two probably don't, although there's still some legitimate questions about Mars? How did all that kind of come to be? Well, you kind of have to begin that process by starting to look at the very early part of the solar system. And again, I caution a couple of cautions here. First of all, this is not what I do for a living, so I'm kind of, this is what I know about it. And secondly, I don't think the story is really completely understood, how our solar system came to be. One of the really great things about the current epoch in astronomy, where we're beginning to be able to actually observe other solar systems, is it's provided some real clues about how these things actually came to be. But there's still some pretty good ideas that have been around for a while now. So the early solar system would be a period of time after the sun has formed, but the early solar system probably looked a lot like this. It was just basically a cloud of stuff, relatively small particles in many cases. Those small particles were probably mostly silicates, again, but composed of lots of other elements. They were probably the remnant of earlier stars, right? The formation was caused as a result of stellar evolution and stellar death. So there was this kind of cloud of stuff out there, basically, where we are now. And, if you really want to get philosophical, all of our atoms were in this thing, right? We were all out there floating around together. What's thought to happen is, or the theory that's been around, by my understanding, for the longest period of time, is what's called the nebular hypothesis, right? So that original cloud of stuff, that nebula, was probably interacted on by shocks or forces from surrounding objects. These produced gravitational differences, and under the force of gravity, that nebula started to contract, right? And as it started to contract, pieces of it would interact with each other. They join, they become larger and more massive. Because they were more massive, they had more gravity, they attract other things, right? And it becomes this process. And what that has a tendency to do is two things. First of all, it starts collapsing the gas cloud, right? It starts to become more compressed, but it also starts to form it into a disk. So this cloud probably had some angular momentum, right? It was rotating. And anybody's ever like ice skated or something knows, you know, if you're one of those people that can ice skate well enough to twirl around, which I certainly can't, but you know what I'm talking about, right? You've watched people, and so angular momentum is always conserved, right? It's always going to remain conserved as long as there's not an outside force, a torque or something like that acting on it. So if you think about that ice skater, right, twirling around, they pull their arms in, right? What they basically are doing is kind of contracting themselves, and they'll start twirling faster. And something kind of analogous to that would be happening in this cloud. This rotating cloud would be gathered together by its own gravity, pulled together by its own gravity. Because that angular momentum it has, there's nothing out there to act on it, right? There's no friction or anything like that. So it's going to start to rotate faster and faster. And as it rotates faster and faster, that's going to generate centripetal acceleration, right? It's going to pull it further, pull it in with even more force. So eventually what happens then is a mass begins to form at the center of this thing, and that would be a protosun. And as that mass begins to collapse in on itself, it starts heating up. The gravitational force on it starts to pull it together more. It gets hotter and denser and hotter and denser, until eventually it reaches a point where nuclear processes can begin to happen. Fusion essentially can begin to happen, and it's a star. So at that stage, it probably did kind of look something like this, right? There's the sun there, the newborn sun. Here's all that stuff around it. You can see how it's all in kind of a stripe here, right? Well, all of that, all of those rings of material then are going to begin to kind of interact with each other, right? So you get these rings of material around the protosun. They all start interacting with each other. They collide. They get bigger and bigger, and eventually they sort of pare themselves down to a few relatively large objects, and those protoplanetary rings then form a series of planets. This has kind of been the idea about how planets form for quite a long period of time. There's actually some problems with this, though. One of them, and this is that accretion process, right? Things that are forming by kind of smashing into each other, basically. One of the problems with this whole theory is that there's some things it really can't account for. And one of the things it doesn't account for particularly well, or it doesn't have a complete description of, is it doesn't really account that well for what the planets are actually made out of. So if you start looking at our neighbors here, the terrestrial type planets, they're made out of mostly iron and silicates, right? Heavy stuff, heavy elements. And that probably makes sense because they are closer to that source of gravity, right? So they're going to be accelerated a little bit more by the acceleration of the rotating protoplanetary disk and the sun itself. The gas giants out here are composed mostly of hydrogen and water ices and are very rich in organic materials, carbon mainly, which the inner planets really are not, which is odd to think about since we're all organic material, but we're not quite as, we come from planets not quite as rich in it. And there's as I mentioned, there's a pretty sharp dividing line between those. It's actually marked by the position of the main asteroid belt. And people who are interested in this sort of thing that study the evolution of this have come to call this the Great Divide. Right, it's the people that came up with this name were at the Southwest Research Institute, which is in Boulder. At least their branch is in Boulder, Colorado, which is 15 miles away from the Great Continental Divide. So they kind of took their name from that. I'm originally from Colorado, but I like to point out from people there's actually 4 continental divides in North America, and the one that runs along the Rockies is just one of them. So calling it the Great One seems a little, I don't know, presumptuous to me, but anyway, that's an aside. Anyway, so how did this happen? How did it happen that we have these planets here that are richer in heavier stuff and not so rich in heavier stuff as you get further away? And again, that planetary nebula hypothesis does kind of account for that, right? Because if you just think about how massive objects moving around are going to concentrate, right? You would expect the more massive things to be closer to the source of gravity and the less massive ones to be further away. So that part works relatively well. But there's some stuff in here that doesn't necessarily. And if you look at the depiction of this, it shows Mars and Earth and Venus, and the sizes here are obviously not correct, right, relative to each other. If you start looking at the actual correct sizes of this, the picture that emerges is a little different. So is all this stuff actually true? I mean, is the Great Divide really caused by angular momentum? Well, the people that have kind of coined this term, the Great Divide, would say no. They'd say what actually happens here is that you got pressure waves that passed through this protoplanetary cloud, and they sort of sorted the material out. So it wasn't momentum and gravity, it was these pressure waves passing through. And there's actually some evidence for this. Radio astronomers using the ALMA array, it's an array of radio telescopes that I believe is in Chile? It's the Atacama Large Something Array, microwave array. And they're using it to make very detailed maps of protoplanetary disks, right? These are planets that have disks of stuff around them. And when you look at these, you do see a ring. So this is actual data right here from ALMA. You see these ring structures here. And as they examine the composition of these ring structures, they find that they're seeing a chemistry there that's kind of similar to what one would expect to produce planets like the ones we have. So this probably suggests that, you know, that this whole Great Divide theory is probably accounting for the chemical composition of the planets a little bit better. What it doesn't necessarily account for is something that you may not necessarily realize at least I didn't necessarily realize was unaccounted for, but that's this. All right, let's ignore Mercury for now. We'll just kind of pretend it's not there. Venus, Earth, Mars. See a difference between them? I mean, there's an obvious difference, right? Earth is pretty and has life, and Venus is like hell, and Mars is really, really cold. But there's another pretty big difference between these. You know, it's often said that Venus and Earth are twins, right? Twin planets, roughly the same size, roughly the same mass. Mars is a lot smaller than either one. Why is that? So let's talk about Mars. We'll begin by looking at Mars. This is our neighbor Mars, nice picture of it. Almost looks like a place you might see on Earth a little bit, although it's certainly not on Earth. But the thing that is most noteworthy about Mars, or one of the things that's noteworthy about Mars, is it's smaller. It's quite a bit smaller than the Earth. And in fact, if you look at a comparison between them, this is all in miles, so it should be easy. It's a little more than half the diameter. Some of the other things that you might notice here, look at the atmosphere here. Atmosphere on Earth, about 1.014 kelvins, 1014 millibars, right? Atmosphere on Mars, 7 to 9, almost non-existent, right? Almost no pressure. And what atmosphere is there is mostly carbon dioxide. So anybody ever see the movie The Martian or read the book The Martian? Great book, great movie, but the whole premise of it probably could never have actually happened because a sandstorm or a windstorm on Mars would simply not have enough force to move anything the way it did in that movie. So obviously the author of that book used a little bit of a scientific license there, but you know, I forgive him because it's a really good book. Anyway, not much atmosphere, not much magnetic field, which tells you something about the internal structure of it a little bit as compared to the Earth's very strong, but in a lot of other ways, pretty similar, right? Similar axial tilt, kind of the tilt relative to the plane of the ecliptic. Rotational period is very similar, almost identical, in fact. Obviously, the gravity is quite different because Mars is a smaller and less massive object. But this range of temperature here is actually not that different either when you start comparing it to other planets, right? Obviously, it never gets very warm on Mars, and then most of the time it's really, really cold. But there's places on Earth that are, you know, comparably cold under some circumstances. So this range of temperatures even isn't really all that different. But the big difference, as I said, is up here, the size. So how is it that Mars ended up being as small as it is? And this was a problem that I can remember, you know, learning about when I was in college, and nobody really knew the answer then. So if you run a simulation of a solar system, right, there are astronomers, scientists who create kind of mathematical models of how solar systems form, and you run one using the current conditions and all that protoplanetary disk stuff that we just talked about, this is what you get, right? You get a Venus and a Mars that are about, or a Venus and an Earth that are about the same size as Venus and Earth, the current ones. You get a really big Mars, one that's a little bit bigger than Earth. Then you get an asteroid belt with a bunch of little Marses in it. And then you get the Great Divide and you get things like Jupiter, right? So this is pretty cool in a lot of ways. It does kind of reconstruct this dichotomy between the rocky planets and the gas planets. But if you look at what we actually have, it's more like this: Venus and Earth, you know, and then a little tiny Mars, and a little asteroid belt. So why did that happen? You know, it led to a theory that I think has the coolest name of any theory I have ever encountered, at least in astronomy. That's the theory of the grand tack. So, anybody in here a sailor? Right? You know, sailors, when you sail against the wind, basically they configure the sail so it operates like a wing, and it's called tacking, right? It's sailing against the wind, basically. So the grand tack then, I don't know exactly why they use this as an analogy, but what it basically says was that the planets are all in different places now than when they originally formed. So Jupiter, under the grand tack theory, it would actually form much closer to the sun and then moved away, it tacked through the solar system. Saturn, kind of the same. And in the process of moving around, it kind of perturbed everything, right? It disturbed the formation of those inner planets. There's the asteroids right there, so the inner planets would be down here, right? And one of the things it probably did, particularly the grand tack of Jupiter, is it deprived Mars of material, right? Earth grew to the size it did because it accreted a bunch of smaller objects, right? Same with Venus. Mars, the same, except it didn't have as much stuff to work with, right? Jupiter had stolen all of its stuff. So, and we're going to see that as we go along here, Jupiter, kind of a bully, right? It sort of bullies the whole solar system a little bit because it's so big. Well, that's thought to be the reason why the grand tack is thought to be the reason why Mars is considerably smaller than than Venus or the Earth, and smaller than it probably should be, given the current understanding of planetary evolution. So that's probably the answer to why Mars is small, right? Why it's the little guy of our neighbors. As far as what Mars is like as a planet, I borrowed this from another slide presentation, so I thought it gave the answers in a pretty simple way, right? Mars is really, really dry, really, really cold, doesn't have much air to speak of, and we've already said, and what air is there is really carbon dioxide, and it's intensely irradiated. I don't know, again, looking back to the Martian, I don't know if you've ever read this book, but there's a line in it where the character says, "There's so much radiation that if I exposed myself to it, my cancer would get cancer." And it's, I mean, it's pretty accurate. Has no magnetic fields, so really no protections, right? It does have a seasonality. The orbit of Mars is a little bit more eccentric than the orbit of Earth. It's a little more elongated, right? So the seasonality is actually a little bit more pronounced in that sense. Also, it takes a longer amount of time for the Mars to orbit the sun. But in other ways, it does kind of have a seasonality. It has a solstice, it has a winter solstice and a summer solstice, it has equinoxes, right? And they show up in observable features on the surface. The polar caps will expand and contract in unison with the Martian seasonality. And again, the axial tilt of Mars is very similar to that of the Earth. So its distribution of radiation is pretty similar. So Mars kind of has a little bit of a seasons, very similar in how they form to the Earth seasons. But again, we kind of come back to this business of the atmosphere, right? Very thin, virtually no oxygen, mostly carbon dioxide. It probably had some oxygen at one time. The problem again with Mars and retaining its atmosphere comes back to its size, right? In this case, the size matters. The mass of it is really what matters. And so what's thought to happen is something called Jane's escape, which is that all those molecules can escape. They can reach an escape velocity because of the of the less gravity. So it's thought that Mars's atmosphere essentially just escaped. And you contrast that to the Earth's atmosphere, much thicker, oxygen, water vapor, all that stuff we sort of rely on. This is all just, a dead giveaway that Earth is supporting life. But Earth does have Jane's escape. Bits of the atmosphere do escape. They get replaced by other things like volcanism and outgassing and stuff like that, but not at the rate that the atmosphere of Mars escaped. Here's probably the closest analogy to what it's like on Mars here on Earth. This is one of the Antarctic dry valleys. This one's called Murray Dry Valley. There's 3 of them, Taylor Dry Valley and another one I can't think of. And this is probably the closest analog to what it's like on Mars. But having said that, and there are actually people that go here to try to study what the situation would be like on Mars. I've known people that have spent considerable amounts of time there. And basically being here, being in the Murray Dry Valley or one of these Antarctic dry valleys would be like being on the Riviera compared to being on Mars, right? So even though this is the closest analogy you can think of, you can go here and breathe. You can go here and not freeze to death, even though it's pretty dang cold a lot of times. You can go here and not be irradiated, but still, this is probably the closest analogy. So I actually met some people that worked there, and one of the things they were thinking about was what sorts of life forms might live here, which would be analogous to things that might still exist on Mars. So if you ever actually want to get at least some sense of what it's like on Mars, this is probably about as close as you can get. Mars has a topography associated with it, as do probably any of the terrestrial planets. This is actually an elevation map. You kind of see, if you look at this and kind of draw back a little bit, you kind of see some things here that are pretty interesting. It's obviously a heavily cratered planet, but the ages of the craters and the types of craters are very different depending on where you are in the Martian surface. And there's areas that are much less cratered than others, which suggests probably that the ages of those surfaces are a little bit different, right? Because a heavily cratered surface is going to be older, exposed for a longer period of time to bombardment by objects. And so that's kind of what this sort of suggests here. So if you kind of look at the relative ages of these things, it varies depending on where you are. There are some areas that are relatively large craters, and they're probably an older cratered area. There's some where it's relatively small, and that's probably a more recently cratered surface, and that is thought to be related to periods of bombardment. During the period there was the earlier bombardment, and then what's called the late heavy bombardment, which is actually, I don't know, it was like 1 billion years after the planets formed, so pretty long time ago. But those were thought to be kind of related to the physical structure of the Martian surface. And then there are these areas where there's almost no cratering, and that's really kind of interesting, right? Because it kind of suggests maybe Mars has a history of where it was really different than it is now. So early Mars probably had water. It was probably quite a bit warmer and quite a bit wetter than it is now, and quite a bit denser atmosphere, and probably a more oxygen-rich atmosphere, which kind of leads to the idea that, if there is not life there now, which probably unlikely, there may have been at some point, at least microbial life might have existed at one time. And there's actually some interesting evidence to sort of suggest that. There might have actually been oceans at one time, or something very similar to oceans, and that might account for that structure of the cratering that we saw back here, right? These are topographically low-lying, right, and less cratered surfaces, so that suggests that maybe they were worked by water. So there could have been a time when Mars actually had oceans. Is there life on Mars? Has there ever been life on Mars? Big question, right? $1 million question, $1 billion question, maybe quadrillion, I don't know. Anyway, there's been never been any clear, completely unambiguous, clear answer to that one way or the other. Back in the 1970s, the first probes that landed on Mars, Viking, I believe they were called, they actually had a little experiment built into them that was supposed to test for that. They scooped out a little bit of soil and did a little chemistry with it, and if it produced, the idea was if it produced certain types of gases, that would mean microbial life, and it did. It actually fulfilled the conditions of of what would be considered evidence for life. It's been explained in other ways now. It's probably really wasn't microbial life, but it kind of at least shows you that it's not an easy question to answer. This was something that, I don't know, maybe 25 years ago, this kind of became a thing. This was a meteorite, ALH 84001-0. This was a meteorite that was recovered in Antarctica, a piece of Mars, right? It was shown to be chemically to be a piece of Mars. And when it was examined rather closely, there were these little things that look sort of like microfossils, basically, little fossilized bacteria. And so this was considered possible evidence of not life now, but fossilized life. Where this stands right now, I really have lost track of the discussion a long time ago. I don't think there was ever really any clear resolution of this, other than a lot of biologists, you got astronomers and planetary scientists out there saying, hey, look, life, and biologists are like, not so fast, right? The concern they had was these are way bigger than bacteria on Earth. And so that suggests maybe it was some other just geological process or something.
I think they had, they had, kind of reproduced the soil and stuff like there, and they ended up finding some that made that type of kind of an elongated thing.
Yeah.
So I think that also helped rule it out.
Yeah, but again, the point here is that it's, this is not an easy thing to determine. This is one that's a little bit more subtle, but maybe in some ways a little bit more indicative. This is obviously a close-up photograph of some rocks on the Martian surface, and there's some structures in these that are very similar to, a lot of terrestrial rocks have a biological signal kind of built into them. They formed as a result partially of biological processes. And some of these rocks are very similar to that. They're analogous to those types of rocks here on Earth. So this again is kind of a suggestion that perhaps at one time, this might have been, for example, a remnant of some kind of microbial mat or something like that. So again, not living now, but perhaps an indicator at one time that Mars was an abode of life. So I think the life on Mars question has never been resolved. May never be until, I don't know, maybe humans can get there and do more systematic types of studies. But anyway, but it is an active question, and there is certainly a possibility that if there's not life now, that at least there might have been at one time.
Oh, okay.
Mars is also a planet that has entered the culture in a lot of different ways, right? This is actually something I kind of wanted to weave into all this because, I think the science is interesting, but the stories and the myths are sort of part of our culture in a very, very fundamental kind of way that I don't think we already always realize how much they really are kind of woven into our. So one of the big myths of Mars was that it was an abode of life, right? That it had vegetation on it, that it had water on it. And this was all based on observations made from Earth with equipment that was not as advanced, I guess we'll say, as we have now, and maybe some really active imaginations on one side of the telescope. But regardless, Mars became the subject of a lot of mythology. One of those, of course, was the whole notion of the Martian canals, right? It's all actually, in some ways, it's based on a mistranslation. The guy that first developed this idea, his name was Schiaparelli, was an Italian astronomer, and he thought perhaps he had seen what he called channels, right? Natural waterways. And unfortunately, the Italian word for channel is canali, which sounds a little like canal, right? Which implies construction, right? It implies artificiality. And this led to, myths and stories and ideas that persist to this day. one of the people that really took up the cause of all of this was Percival Lowell. And I guess I should back up and say Percival Lowell gets a lot of grief even now for some of the things that he said, and some of it's pretty justified. But Percival Lowell was actually a pretty talented and good scientist in a lot of ways. Actually, was not trained as an astronomer. He went to Harvard. Comes from a very prominent family, right? One of the Boston Brahmin families. These were super wealthy people. He still has one of his great nephews is on the Board of Regents of Harvard. So this was a super connected family, right? Extremely wealthy. And he was a really good student. He went to Harvard, studied math, which a lot of astronomers in those days did, and was quite a skilled mathematician. Was business, he went into business in Asia, made a lot of money. Of course, already had a lot of money, but made a lot of money. But his passion was astronomy, and particularly Mars. And I think in some ways we indirectly owe him some gratitude, right? Because he founded the Lowell Observatory in Arizona strictly to look for life on Mars. That was what he really wanted to do. That telescope that he built up there was to try to support his idea that there was not only life on Mars, but that was intelligent life. So his idea was that Martians were building these, Mars was this dying world, right? Desertifying world. And the Martians were trying to build canals to bring water from the poles, which you can pretty prominently see the ice caps, right? Down to where it could be used for agriculture. And it was this planet-wide cooperative thing. And Lowell was a pacifist, was very opposed to war, and he used this idea as kind of a model for peaceful planetary cooperation, right? His idea was Mars was this place of, where everyone was working together to try to save the planet, and Lowell found that to be a really compelling idea. So he founded this observatory largely for that reason. Of course, the other thing that we kind of remember him for is he also was very interested in finding a ninth planet, right? What he called Planet X. And one of the people he hired to do that was a young man from Kansas named Clyde Tombaugh, who we actually have a telescope in our club named after him, right? Did you meet him? So did I, actually.
Yeah, at KU.
I met him in Las Cruces when he was a very, very old man, but he was a very gracious man, one of the best encounters I've ever had in my life.
I think he was in his 90s when I met him.
I think he was probably similar to that.
Yeah.
He was actually one of my friends who taught at New Mexico State, lived in the same neighborhood he did, and kind of.
Oh, cool.
So we were out walking one day, and he
Burdett?
said,
Was Burdett, Kansas?
"No, this was in Las Cruces, New
Because
Mexico."
I know he lived in Burdett for a while too.
Yeah. But anyway, he took us in and showed us his homemade telescope. Anyway, sorry, that's a different story. But I don't want to get off on that tangent. But he was really kind of an interesting person. But anyway, so Lowell, he pushed this idea, or he advocated this idea that there was this global civilization, but it was a peaceful and cooperative global civilization. Other people kind of picked up the idea and they twisted it a little bit, right? Yeah. So one of the people that really changed the game here was H.G. Wells. Wrote this War of the Worlds, and in War of the Worlds, the Martians were from a dying planet, but instead of being peaceful and friendly, they were nasty and mean, and they came to Earth. And of course, anybody who's ever seen the original War of the Worlds movie, right? The one that was made in the 60s, I think. I think it's so much better than the more recent one. It just seemed scarier.
So,
I like them both.
Yeah, I liked them both too, but I thought this one was way scarier. But that all comes from H.G. Wells, and of course Orson Welles picked up on it, famous broadcast, all that stuff. But this is another view of Mars.
Even Bugs Bunny's Martin the Martian has a ray gun.
Yeah.
I think that's a reflection of the human.
Yeah. But anyway, this kind of shows you that the myths of Mars kind of penetrate. Here's another myth of Mars, the face on Mars. This was some guy, I don't know, I bought a copy of his book years ago just out of curiosity. It was called City on the Edge of Mars or something like that. Anyway, this guy came up, and he's not the only one. They came up with this idea of there's a city on Mars, right? There's the face that they identify. This was in some of the imagery of one of the earlier And it's nothing, it's not a face, it's just a mesa. It's geologically pretty interesting, but it's not a face, and it's not artificial. And they thought somehow his name was Richard something. I'm sorry, I'm blanking on his name. Anyway, he squinted at these things long enough to convince himself that this was a city that was composed of big pyramids that were like huge buildings, right? What disappointed me about it is in his book he says, if anybody proves me wrong, I'll be happy to retract it, and he's been proved wrong and he's not retracted. Richard Oglet. So anyway, his book's interesting to read as a kind of a psychological study, I guess, but this is not anything real. But it kind of shows you that it still kind of lives in people's imagination, right? That there's possibly something on Mars. I guess his idea was that there are Martians in like suspended animation in here, and one of these days they'll reemerge and, I don't know, attack the Earth or something. I don't know. But anyway, but you still.
It got to be to the point where people were just, pushing it and pushing it. So they had another orbiter where it took an image of the same thing.
I should have put that one on there because it shows that this is just a hill, right?
Exactly.
It's just a hill.
Yeah.
But anyway, it's interesting. I mean, I think geologically it's interesting, but it's not any evidence of life. Mars makes it into the movies a lot. I lost count. Well, I tried to count how many Mars, just out of curiosity today. I tried to count how many movies have been made about Mars, and I don't know, it's got to be in the dozens, if not the hundreds by now. They vary in plausibility, I guess, and purpose, but again, it kind of shows you that this planet has sort of, I don't know, it sort of fixed itself in our minds, right? Even now, this movie was made, less than 10 years ago, I think, maybe less than 5 years ago. And, it still sort of represents something that people are interested in. Right?
One of the things from that movie that I use when I tell kids about it.
Which one?
The Martian.
Oh, The Martian.
The one, what's his name? Is that they've done some, just kind of studies and say what would happen, was that realistic? And what they decided was that he couldn't have lived on the potatoes, because if you had planted potatoes on Mars and they had grown, because of what's in the soil, they would have been toxic. So the first time he ate a Martian potato, he'd be gone.
Yeah.
Yeah.
I don't know. I guess
It had to go so far as to, try to
what would have
make-
been in the toxin? What would have been the toxin?
I don't remember.
Anyway, I mean,
Yeah.
the whole movie is based on a premise that probably never, but it's still a really good movie. Right?
Yeah.
But anyway, but I guess the point here is that it does kind of show that, this still fascinates people. I don't know if you've ever seen this movie, The Angry Red Planet. It's all shot through this kind of weird red filter, and it's just incredibly terrifying. I saw it probably for the first time when I was maybe 11, and I had been left at home alone, and I was watching the movies, and it scared me to death. So anyway, that one lives in my mind a little bit. The big bat rat spider thing just still totally creeps me out.
Is the mission to Mars the one that they had the robot? that
I think
attacked
that's
you?
right. Yeah.
That kind of
Yeah.
left there.
Wasn't it on Mars Attacks, the way they found out how to kill them, they blasted Slim Whitman?
Something like that.
Classic of American cinema, right there.
Yeah. One thing we do know for sure about Mars, though, it's the only planet we know about that is entirely inhabited by robots. So. All right, so that's a little bit of a look at Mars. What about Venus? What about our other neighbor? Well, we already saw that Mars is kind of not a particularly hospitable place, right? Venus is even worse. Venus is probably about as close to the vision of hell as you would ever plan to get. So anyway, how did Venus get the way it is? First of all, Venus is much more similar to the size of Earth, and the mass and the composition and all that stuff. Very similar in many ways. And again, that follows from the theory about how all these things
It's
form.
very bright in the sky.
Very bright in the sky, bright
Yeah.
The brightest thing in the sky after the sun.
after the sun and the moon. Yep. And it'll be a nice sight here for the next few days. If you just look at Venus, it doesn't really look as interesting as Mars does. Look at it through a telescope, it mostly looks like that, right? That's Venus is viewed by an amateur. It just looks like a white blob, basically. Even if you flew by it, this was Mariner 10, very early mission that flew by. you know, it just looks like clouds, basically, which is kind of what it is. One of the things that's different about Mars versus Venus is you look at Mars through a telescope, you're seeing the surface of Mars. Look at Venus through a telescope, what you're really looking at is the top of the clouds. And that actually is part of the story, really, of Venus and how it came to be. So in terms of all the numbers, right, all these things are pretty similar in many ways to the Earth, right? Very similar in many ways. Except look at that one, 470 C, right? Mean temperature of the Earth is what, 30 maybe?
Yeah.
So this is almost hot enough to melt lead. So this is extremely inhospitable. And look at that, the atmosphere is composed almost entirely of CO2. So that's all part of the story. So why is it that way? In fact, if you are looking at what was found by probes and other, you know, most of what we know about the surface of Venus comes from radar data, right? Sending radar pulses that can penetrate through the cloudiness. But there have been probes that have landed. They don't tend not to live very long because it's this incredibly corrosive, destructive environment. But if you look at the layered structure of the Venusian atmosphere, it kind of has a layering that's not entirely dissimilar to the Earth. You know, the Earth's atmosphere has these layers that are defined by temperature trend, right? So the layer closest to the Earth, the troposphere, the temperatures decrease, then you get up to the stratosphere and they actually increase, although they don't get very warm, and so on, right? So it has this kind of layered structure to it. Venus has something kind of similar to that, except the boundary between the stratosphere and its troposphere, its lowermost layer and its uppermost layer, is very sharp, very impenetrable, and marked by a layer of sulfuric acid clouds that are probably the result of sulfur being volcanic sulfur, right? Sulfur being emitted by volcanoes, been acted on photochemically, and it turns it into sulfuric acid. So it's this very corrosive atmosphere. Why that happened probably has to do with the story of how Venus also came to be as hot and as kind of inhospitable as it is. So it's thought that at one time, much like the Earth and possibly like Mars as well, Venus had oceans. It probably had conditions that were somewhat similar to Earth. But in the case of Mars, right, two things happened. Mars was small, it was not as massive because of, you know, Jupiter, the bully, right, keeping it small. And because of that, it lost its atmosphere, right? It couldn't retain it, it didn't have enough gravity to retain it. In the case of Venus, what happened was too close to the sun, right? So, you know, people talk about the Goldilocks zone, right? That area where liquid water can exist. If you're on the outside of it, like Mars is, you're too cold. If you're on the inside, like Venus is, what probably happens is you lose your water through essentially chemical processes. So what probably happened was the oxygen and the water escaped because of temperature. And it left behind this atmosphere that was dominated by carbon dioxide and sulfates from volcanic eruptions. And that produced the thing called a runaway greenhouse effect. And the runaway greenhouse effect probably explains why the Venusian surface is so much warmer than Earth's or Mars's. And one of the people that proposed that idea was Carl Sagan. That was actually one of the chapters in his dissertation. I actually have a copy of his dissertation. In one of his chapters, he proposes this runaway greenhouse effect for Venus. So that's likely what happened there. So if you think about it in terms of the Goldilocks zone, right, it kind of explains what happens on the hot side of the Goldilocks zone. It's basically just... The other thing that probably happened was Jupiter again, right? The kind of photochemical processes don't fully explain this, but if you consider that Jupiter making that grand tack and kind of moving things, it probably caused Venus to get closer to the sun, and that's what kind of initiated this process of it losing its atmosphere and its water. So again, did migrating Jupiter turn Venus into hell? Possibility, kind of gets back to that grand tack sort of thing, and it once again just illustrates the fact that Jupiter is kind of a bully, right? It just sort of bullies all the other planets. But here's some of the topography. You know, Venus has topography just like Mars and the Earth do. The only reason we know about this is radar, right? So this is data that was taken from the Arecibo radio telescope, which collapsed a few years ago. It's no longer there. I think they've taken it completely away now. It's just a hole.
Yeah,
But
sad.
But at one time it was used, it was powerful enough to send radar pulses all the way to Venus and back. So and so a lot of what's known about the surface properties come from radar data. There have been probes that have actually landed. This is a Russian probe that landed in the 1970s. I think it lived for, this thing was basically built like a tank. And it lived for, what, 15 minutes or something like
It
that?
was more like an hour or something.
But
Pressure.
the pressure of it, it's like being, at the bottom of the ocean. The atmospheric pressure on Venus is literally like being at the bottom of the ocean. So between the pressure and the corrosive environment, but this gives you some idea what it looks like, not a particularly hospitable looking place by any means. Here's some other images. These are Venera 9 and 10. Again, these were Russian probes that sent back some images. So there are a few images of what it looks like on the surface. There's a lot of talk about terraforming, right? Trying to turn a planet into an Earth-like planet. And in fact, Venus would probably be easier to terraform than Mars. There's, more, I think terraforming Mars gets a little bit more attention. In fact, we have a game, my family has a game called Terraforming Mars that we play every once in a while where the goal is to terraform Mars. But Venus would probably, because it does have a thicker atmosphere, would probably be a better candidate. Neither one of them are very good, right? The whole idea of terraforming is probably technology that's way far away, if ever. But Venus would probably actually be an easier planet to terraform than Mars would. Venus doesn't quite get the same level of crackpottery, I guess, that Mars has, maybe because it never really kind of entered the imagination in quite the same way. But that doesn't mean it completely free of it. So one of the crackpot ideas that involves Venus a little bit was by this guy, Emanuel Velikovsky. And Velikovsky came up with this very fanciful idea about how the solar system formed. And his basic idea was that there were originally 10 planets, right? There was this other planet that was kind of out there where the asteroid belt is now. And it had a civilization on it. And those people visited Earth. So they were called the Anunnaki. And so some of the ancient astronaut crazy people feel like the ancient astronauts were actually from Lemura, was what they called this planet. And so Velikovsky was kind of the wellspring of all of that stuff. And his book, Worlds in Collision, is fascinating. I think I read it in high school, and it's a cool book. It's, if it were labeled fiction, it would be a wonderful book, but it's not. But his idea was that Lemura was destroyed, but this great cosmic cataclysm, the planets careened around, running into each other and causing destruction. And Venus was ejected from Jupiter as a large comet and ended up in its orbit. So that's how Venus kind of fits into the Velikovskyan view of things. Of course,
that top picture supposed to be?
Good question. I was just coming to that. One of the things that Velikovsky, and he wrote like 15 books, right? This was just the first one. One of the things that Velikovsky tried to use his Worlds in Collision idea for was to explain cataclysms in the Earth's history. And they were caused by close passes of other celestial objects. And in the Velikovskyan view, a close pass of Venus right about the time of the Exodus caused the Red Sea to part. So what this is the Red Sea parting, right? So there's Moses right there. He's presumably the children of Israel are back here somewhere. And that was Velikovsky's explanation for what caused the parting of the Red Sea, which was Venus flew by. Of course, this is, it's utter nonsense. In fact, one of the people, there's Carl again, One of the people that actually took Velikovsky serious enough to rebut him, which you got to give him some credit for doing that, was Carl Sagan. So he wrote this, "A Scientist Looks at Velikovsky's Worlds in Collision," and very, very professionally explained why this could never have happened, ever, ever, ever. But again, a pretty interesting read. So this is one, I guess, kind of crackpot idea that does involve Venus. Venus and Mars actually figure quite a bit in mythology as well. And again, there are carryovers into this. You know, in mythology, Venus and Mars, Venus was the goddess of love, right? Mars was the god of war. You would think they would be opposites. Apparently, opposites did attract, and they were lovers. They were a illicit romantic couple, I guess you could say. And they were found out. There they are, Ares, god of war, right? These are the actual names of them, Ares and Aphrodite, right? They were found out. Vulcan found them out, right? Caught them apparently in a compromising position, and cast his net over them, Vulcan's net. So, and then he deposited them for public display, and that was how Venus and Mars kind of, or Ares and Aphrodite were humiliated, I guess, by this event. One of the things that I found interesting in this is Vulcan's net, right, has become kind of a thing in and of itself. Anybody here play pickleball? You know what pickleball is, right? It's this little game that people, it's kind of like tennis, I guess. This is a pickleball net. Look at the brand name there, Vulcan's net, right? So anyway, so if you ever play pickleball with a Vulcan's net, you know now why it's called that. Anyway, and of course there's modern myths in this. Venus and Mars played big roles in the mythology of astrology, right? You know, the love signs and the war signs and all that sort of thing. These kind of come up. So when Mars and Venus begin a conjunction, 4 signs will have a passionate love life, which is happening now, so we'll see. But anyway. And of course, there was this one, right?
Yeah.
John Gray wrote this book, but you know, but again, this is kind of this whole notion that, you know, there's Venusian qualities and those are associated with women, right? Nurturing. There's male qualities, which are usually war, right, associated with men. Those come from the mythology, right? The reason why he used this, John Gray used, and again, this guy's written probably 20 books by now, all on the same subject or similar subject. This all kind of follows from that. I don't think this is one of his, but this one, that, you know, I'm sure the women get a good laugh out of this one. But anyway, I like that, you know, he's reading Tile Grouting Made Easy, and she's reading this one. Anyway, but again, these follow from this mythology that's developed there. So here's one that I kind of like, right? This was an album that came out by Paul McCartney and Wings, right, back in the 1970s, Venus and Mars. One of the funniest things that I can remember overhearing, right? Overhearing a conversation. I was probably about 19, I guess, and I was listening to kind of, you know, slightly eavesdropping on a conversation of these 2 young girls who were probably about 12. One of them said to the other, "Did you know Paul McCartney was in a band before Wings?" that comment has stuck with me ever since. You know, it's like, okay. But anyway, so yeah, but again, it kind of, you know, illustrates this culture associated with it. So are there any prospects of actually visiting the neighbors? And I think there probably are, but it's not going to be that easy, all right? Mars would probably be much easier to visit than Venus for what might seem like obvious reasons, but still not easy. It takes a long time to get there. You know, you got to either take food or figure out how to grow it, hopefully without poisoning yourself. You have to figure out the fact that it has no magnetic field, which means that there's no protection from all that stuff that. So this would be a difficult thing to pull off. I mean, I'm hopeful that somebody will do it in my lifetime, but I wouldn't bet an awful lot on it, to be honest with you. There are people that will, of course.
Yeah.
I think Elon thinks he'll be there in 5 years. He had a great quote or something like, he said, I hope I die on Mars, but not on impact. And, I thought that was a pretty good quote. I don't know, I guess I'm skeptical, but I will reserve judgment on it.
Yeah.
So,
Yeah.
Venus and Mars, these are our neighbors. Any questions?
Very interesting.
Well done.
All done.
Good job.
Thank you.
He'll actually land on Mars before he releases the Cybertruck.
Yeah.
Oh,
Well, I don't know. I guess when I was a kid and we went to the moon, it was like, okay, we'll be on Mars in 10 more
Oh,
years,
yeah.
right? And
Yeah.
I don't think anybody's really come to grips with how difficult it's really going to be. One of the things that I think people often don't. I participate in some of these online discussion groups where people talk about this kind of stuff, and